Hi students, welcome to the associative property of convolution sum. The property is written here: x of n star h1 of n, that is convolved with h2 of n, gives x of n convolved with h1 of n star h2 of n, right? This is what associative property. What is it telling? That is, see here from this block diagram, what we understand, this diagram represents left hand side, this diagram represents right hand side. This indicates if LTI system, if two LTI systems are connected in series or cascade. Series is nothing but cascade, right? The overall impulse response is the convolution of individual impulse response. Here you see, this is individual impulse response, right? The overall impulse response is the convolution of individual impulse response h1 of n and h2 of n. This is the meaning, right? This is a very important statement. Okay, right. So here we see that how we are going to prove this property, right? Proof. Let us assume that x of n is the input, y1 of n is the output. This is related by the equation. The output y1 of n can be obtained by convolving x of n with h1 of n. Yes, okay. This I write as an expression: p goes to minus infinity to plus infinity, x of p h1 of n minus p. Instead of writing k goes to minus infinity plus infinity, x of k h of n minus k, I use p because I am going to apply this input to here. Again, I have to apply convolution. There I use the variable k. So if I use k here, there also I use k, means we will get confusion. So I use p here first. Now this y1 of n is the input to the second system. So y of n, the output of the second system, is the convolution of input and the impulse response. Input is y1 of n, impulse response is h2 of n. So I can write y1 of n star h2 of n. This is the output of second system, right? Now I use the term k, right? So we know in general how we write y of n: x of n star h of n. K goes to minus infinity to plus infinity, x of k h of n minus k. So this h of n replaced by n minus k. So h2 of n I first write as h2 of n minus k. Summation goes from k goes to minus infinity to plus infinity. In x of n, that is input, this is input, this is impulse response. Here input, impulse response. Impulse response I replaced with the n minus k. Input I replace n with the k. So this is my input because y1 of n is the input here, right? Where n must be replaced by k. Here we have n at only this point, so that only must be replaced by k. Other thing should be as it is. So p goes from minus infinity to plus infinity. X of p h1 of k minus p. Now the equation is completed, right? So directly we can write. In order to make you understand, I am writing like this. Okay, now we manipulate this equation, right? If I manipulate by if let L is equal to k minus b, this indicates y of n is equal to summation. I am going to work with L and k, right? So this I want to replace with k, I want to replace. So p will be a constant factor. I take it outside. P varies from minus infinity to plus infinity. X of p, right? I am going to work with L and k. So k goes to minus infinity to, sorry, I keep here k as it is. First I do change here h1 of k minus b. K minus b I replace with L. So h1 of L. This indicates k is equal to L plus p. So h2 of n, k is equal to L plus p, so it will become minus L minus p, or L I write as n minus p minus l. Why I am writing? There is some reason, so that's why I am writing n minus p. Both are same one, right? So n minus p minus l. Now I want to replace k with l. So here k goes to minus infinity to plus infinity. So I want to replace k into l. So this is l. So if k is equal to minus infinity, what will happen? If k is equal to minus infinity minus p minus infinity. So l is minus infinity. If k is equal to plus infinity here, I want to replace l by k. So k, when k varies from minus infinity to plus infinity, what is the equivalent l variation? That's what I am finding. So if k minus infinity means l is equal to minus infinity. K plus infinity means l becomes plus infinity. So the limit changes from l is equal to minus infinity to plus infinity. Are you understand the logic? Okay, now you see this is what we got, right? So now v goes to minus infinity to plus infinity. X of p, this area. In this part I write as h of n minus p, right? So why I am writing this area as h of n minus p? See, you see this equation appears a convolution between h1 and h2 n minus p. Are you understanding the logic? Why? You see, what is the general convolution equation? X of k, h of n minus k. So it is appearing like h1 is convolved with h2 n minus p. Yes or no? So this is a convolution between h1 and h2. Instead of x we have a h, instead of h we have a h2, right? And that is y of n. So here you see y of n. If here n, here we get y of n. Here n minus p is there, so let us assume h of n minus p. It is a convolution between two impulse response, so I write as h of n minus p. Why am I writing h of n? If it is only h of n minus l, I write as h of n, but here n minus p. Here you see n minus k. Instead of k, here we have l. So it is like h1 of l, h2 of n minus p minus l. So here n means y of n, here n minus p, so it is h of n minus p. Why I am not writing y of n? Y of n is a convolution between input and impulse response. It is like a convolution between two impulse response, h1 and h2, h of n minus p. So I write as h of n minus p. So what will be h of n then? H of n I can write as summation l goes to minus infinity to plus infinity h1 of n h1 of l, so h1 of l, h2 of n minus k minus n, right? So that's why n minus l. Clear or not? So it is like this equation, x of k, h of n minus k, it is h of l, h of n minus l, general convolution equation, right? So this is my overall impulse response. It is a convolution of two impulse response. So I can write, you see this equation I can write as y of n, x of n star h of n. Right? Why I am writing? You replace p by k. P is a variable, just variable. Instead of k, we have it is like a p. You see, if you replace p by k, minus infinity plus infinity, x of k, h of n minus k. Replace p by k. We get this one. This is nothing but x of n star h of n, right? So this h of n we got from here. Yes or no? So that is our overall impulse response. If it is h of n minus p, this is like this. H of n is this one, right? What is this? This is a convolution between h1 of n star h2 of n. So I can write, you see, I can write this one as x of n star h1 of n star h2 of n. So that is what overall impulse output. So overall output is the input and a convolution of two individual input. That's what associative property statement I told. So this is the proof. Thus it is proved. Right? I hope you understand this concept. If you have any doubt, please ask me in comment section. I will clarify. Thank you.